There are many methods that we can use to determine the identity of a crystal or gemstone. No one test will give us a conclusive result, but doing a series of tests will give us a set of properties which we can use to help us form our opinion. Specific gravity sounds really scary, but you'll find that it's one of the easiest and best tests that you can do to identify some of your crystals. I'm going to show you a really easy way to measure specific gravity without needing some expensive instrument. All you will need is accurate scales and a calculator. As long as your stone is in a pure form and not a blend of different minerals, then its specific gravity will help you to narrow down what it is. An excellent example to use for this test is the black stones tourmaline, obsidian and onyx, because they each have a unique specific gravity, so this test will show us which one is which. So find out what the specific gravity range is supposed to be for your samples and write those figures down. So what specific gravity actually is a comparison between the weight of something and its volume, that is, its density. With minerals, this is calculated by comparing the weight of the stone and then in the end dividing it by the weight that water would be if it took up exactly the same space. So all we need is a set of scales that are accurate to at least 2 decimal points. They also need enough capacity to weigh a cup of water. These scales here will measure up to 200 grams, which is enough for me to zero in a cup of water, with some room left over for the test. We take a piece of paper and we write down the weight of the stones first. Then what we'll need to do is weigh the stones suspended in water. So we place a cup of water big enough to immerse the stone, and we need to somehow suspend the stone in the water without touching the sides or bottom. If I could tie a string around them, I would do that, but that's not so easy. So with pieces like this, I've made this little cage that I can use to suspend the stones, and I've even put a little black mark there so I can immerse it at exactly the same point each time to make the test as accurate as possible. Make sure also that when you zero in the scales with the cage suspended in the water, that when you place the stone in, don't let any water drip out, because that will change the reading as well, that small loss of water. What this means is that when I place the stone in the cage and immerse it to the same point, the weight that I'm getting on the scales is actually the weight, the water displacement caused by the stone. It is the weight of water that would take up the same space or volume that the stone is taking up. It's called the stone's weight in water, but what it is actually the weight of the water that's being displaced by the stone. Be sure not to touch the sides or the bottom, and zeroing in the scales with the cage on its own means that the result won't include the volume of the cage as well. So we then write down the readings from the scale when we suspend each stone in the water. So however you choose to hold the stone, make sure that you do your best to get a reading of the stone only by zeroing in the holder as well as the cup. So that's it. We just take a calculator and we divide the weight of the stone by the stone's weight suspended in water. The result is the specific gravity of the stone. We can then refer that to the known specific gravity of the stone, and you can see in this case that the specific gravity is very close to the exact specific gravity listed for each of these different minerals. So I've confirmed that we have tourmaline, obsidian and onyx. This test will also work for very small pieces. You can use tweezers, but again just make sure you zero in the tweezers at a certain depth, and then with the stone in, with the tweezers at the same depth. When you know the specific gravity, you can rule out other stones that have a very different specific gravity.